this video, we're going to talk through the process of solving quadratic functions by taking the square root. To begin, we're going to talk through what actually happens when you take the square root, the action of taking the square root to get rid of the power of 2. So for the first example, number 1, x squared equals 9. In order to get rid of the power of 2 there, I have to take the square root on the left-hand side. And whatever I do to one side, I have to do the other side. And then the square root and the power of 2 cancel each other out, so I'm left with x on the left-hand side, which is the whole point of this process, to get the variable by itself. And then when I take the square root of a number in order to solve for a variable, I'm going to have two answers, the positive and the negative version. Okay? In this case, I'm taking the square root of 9, which is a perfect square, and that breaks down to 3, so I have to have positive 3 and negative 3 as my answers. And just real quick, why that is why I have to include both the positive and negative version, because if we go backwards and square both answers, positive 3 squared equals 3 times 3, which goes back to positive 9. And then if I do the negative version, negative 3 squared equals negative 3 times negative 3, which also goes back to positive 9. Okay, so that is why, mathematically, when you take the square root to solve for a variable, you have two answers, the positive and negative version. Now, for example 2, I just wanted to show you, if you're taking the square root of something that's not a perfect square, how I would write that answer. So I still have to cancel out the power by taking the square root of both sides. So now I have x equals, in this case, 5 is a prime number, and it's not a perfect square, so you can't simplify the radical, and it doesn't break down to a whole number, so we just have to leave it in its radical form. So the positive version of radical 5 and the negative version of radical 5. Like so. And again, if you notice, anytime you're solving a quadratic equation, you will have two solutions. And the solutions can look different, very different actually, which you're about to see in these equations down here. So this is something a little bit more like you're going to see as you practice this skill. And as I look at these four equations, the main thing that jumps out at me that tells me that I can solve by taking the square root is that all four only have one x that is present. What I mean by that, typically in standard form it would be, you don't have to write this down, but it would be x squared plus x minus 4, something like that equals 0. In this case, there are two variables present. So for numbers 1 through 4 down here, I hope that you can see that each equation only has one x that is present. So that is a big clue to me that I can solve these equations by taking the square root. Because the first step in this process for all of these is to isolate or get the variable by itself. And so I'm going to show you 4 different ways that plays out, and then you're going to practice these as well. And so for number 1, 4x squared equals 28. On the left-hand side, the variable lives, and the 4 is multiplying with the variable. So I have to divide both sides by 4. And that leaves me with x squared on the left-hand side, and that's going to equal 28 divided by 4 is 7. And now I have that variable by itself. It still has the power, and this is where I can apply the inverse property of taking the square root. But I was successful in getting the variable by itself. So now I can go ahead and take the square root of both sides to cancel out that power of 2. And remember, the action of taking the square root will leave me with two answers, the positive and negative version. So in this case, again, I have to think, I'm taking the square root of a 7. That's a prime number, and it's not a perfect square, so it has to stay as is in its radical form with positive 7 and positive radical 7, and then negative radical 7, or square root of 7. So the first answer, or the first equation, is solved with two solutions, the plus and minus form of radical 7. Moving on to number 2. A little bit different. Hopefully you notice the difference. The variable has a plus 3 with it, and both of those terms are underneath the power. So they're both being trapped underneath the power. Over here, it was just the x was being trapped by the power. So in this case, since it's a quantity squared, we have to get that quantity by itself. The quantity x plus 3 is on the left-hand side, and there is nothing else. There's no other number. Like you see down here in number 4, there's this 3, so this one would have an added step. I would have to move this 3. But this number 2, there's no other number with that x plus 3 that's being squared, so I can immediately jump to the inverse property of taking the square root of both sides. All right? Taking that square root cancels out the power, which frees what's underneath the power. In that case, the x plus 3 becomes free. And now, again, the action of taking the square root of 9 will leave me with the answers of positive 3 and negative 3. Please note, whenever you take the square root of a number, you're going to have two answers, the positive and negative version. And then I have one more step to solve this because as you notice, the x is on the left-hand side. It's not by itself yet. So in this case, I have to subtract 3. And on the right-hand side, I have two numbers to subtract 3 from, the positive and negative versions. So my final answer, that 3 on the left-hand side cancels out, so I'm left with x equals 3 minus 3, which is 0, and negative 3 minus 3, which is negative 6. Leads me to two solutions. Remember, when we're solving quadratics, we will always have two solutions. Two more examples before you try these on your own. I will jump to number 3. Let me get this situated here. There we go. And then we'll try number 4 as well. So for number 3, again, I noticed there's only one variable, so I can treat it like a linear equation first. I have to get b squared by itself. In this case, I have to add 4 to both sides. All right? Cancels out on the left-hand side. I get b squared equals 16, and then I can apply, or take the square root of both sides, cancel out the power. So I take the square root of left and right. I'm left with b equals, the square root of 16 is positive 4 and negative 4. Pretty straightforward. And then finally, this will be the most difficult type of problem you'll encounter when taking or solving with the square roots. It's the same process as what we just did with number 3. If you can visualize here, this b squared stood alone. In this case, the variable is the quantity being squared, so I have to get that quantity by itself. Same process, I have to add 3 to both sides, which leaves me with the x minus 5 squared equals, that cancels out, negative 23 plus 3 becomes negative 20. Now this is where it's going to look a little different, because now what's being squared, the x minus 5, is by itself, so I can go ahead and take the square root of both sides. But this situation over here will play itself out a little differently. So the root and the power cancel out. I'm left with x minus 5 equals, and again, now I have to think, what's happening? I'm taking the square root of a non-perfect squared number, which is 20, but it's not prime either, so I know that it can break down. And also, this should jump out at you. We're taking the square root of a negative number, which means that my two answers that I'll have after this process will be imaginary, meaning they're going to have an I with them. So I can factor tree this 20 because I know that it's not a prime number. I know that factors of 20 are 4 and 5. 5 is a prime number, so it can't break down, and I can break down 4 into 2 and 2. And if you remember this process, you can circle the pairs. They come out of the radical as just itself, so 2. And now I need an I because we're taking the square root of a negative. And what stays in the radical is this 5 that didn't have a partner. All right, so that's the positive version of the number. It's a little bit different looking. It's not as pretty as this whole number of 4, but that still is the number, and that's the number we're working with. That's the positive version, and now we're going to have the negative version as well, 2i, or negative 2i, radical 5. All right, so this whole process of taking the square root of a negative 20 leads me to these two answers of that, 2i radical 5 and negative 2i radical 5. And then the last step, because again, we're still not done, This x is not by itself yet. I have to add 5 to get rid of it on the left-hand side, and then I have to add 5 to both of these numbers. Even though they're imaginary, I still have to add the 5 to them on the right-hand side. So my final answer, z, there's 2 of them. And this is how you need to write it. This jumbled looking thing right here is called a complex conjugate, meaning it has a real part, which is 5, and you have to write that first, so 5. And then I'm going to put plus, because the imaginary part up here is positive, so 5 plus 2i radical 5, and then comma. To write this one out, I still put 5, and it's a positive 5 because we added it to both sides. But in this case, the imaginary part is negative, so 5 minus 2i radical 5. And it needs to be written like that. You have to write the real part first, then the imaginary part second. And those are the 2 answers that you will have for that equation. Thank you so much for watching.